Hello, everybody. Welcome, welcome, welcome. I probably shouldn't have made myself this small, but yeah. It is good to be back on the air. It's definitely good to be back on the air and not in the air falling. Yeah. Hello, everybody. My name is Markiplier. Yeah, I'm gonna do some coding tonight. I don't know if I can actually get his voice register, but yeah. Good morning, good morning, good morning. I have about an hour before or like an hour and a half to like do this shit because I gotta go outside before all the hunters get there with my gun and pistol and shoot at deer. So yeah, we do coding around here and we go outside. It's perfectly balanced, perfectly balanced. I just don't have a coding job at the moment. But yeah. I just also I'm also got my account like restricted on Discord, so that's kind of fun. And Discord hasn't won't tell me why. So like I can't literally post, but I can post through my bot, which doesn't make any sense, but okay. Oh my god. But yeah. Anyway, let's stick myself down here. I have some music playing in the background. But yeah. Anyhow, let's get started. So what is Structy, by the way? What the heck is Structy? What is this? Why would I even bother doing this? Well. Because there are companies out there that want you to my depression moments before stream, my depression after. Wait, what? Oh, Elijah, you really like my streams that much? No way. No way. Oh my god. Stop. No my god. I mean, so this is a learning stream. I was thinking of like do a couple learning streams on Mondays and like Thursdays and then like do gaming streams on the last Sundays. I know these aren't super popular, but like I need to learn stuff, I gotta get back into the programming game somehow, and I gotta keep doing it. I can't just stop. I can't stop. But yeah, should it be a stream? I don't know. I guess we'll fucking find out. But yeah, this Structy is something that my friend recommended to me. So we're gonna have to give it a try. We're gonna see how this curriculum goes. It's free for the most part. It's like a freemium, you pay to get more. So like, let me just what was I gonna do? What? Oh God. I always wondered. By the way, if they tell you to learn not to code, I don't know. Learn to code now is really difficult, but like I've learned it so far. I'm just learning extra shit like algorithms because like in they're like coding tests that they'll give you for like the regular stable jobs. They want to know that you know your algorithms, I guess, which is kind of silly and doesn't prove that you can build anything or anything like that. It just proves that you know how to be a good test taker. So yeah, we're kind of learning what algorithms are, I think, and we're gonna do them in JavaScript, of course, because I'm so good at JavaScript. It's a comfy language for me, and everybody uses it, right? JavaScript, so nice. All right, let me get that. Let me get that up there. I need all that focus. I have like one track mind right now. Let's see, window capture X Composite 2. Okay, it's a little bit different on my. Wow, it's been a while since I streamed on Linux. This is crazy. Give me a second here. How about I just do this one? Yeah, there we go. There we go. All right. Here we go. Structy. So I'm gonna go ahead and turn off the music a little bit. I'm gonna turn off the music. Or I'll just mute it because it's just gonna loop on and repeat. And what we're gonna do is we're gonna give this a chance. We're gonna get a nice little introduction to Structy. Let's take a look at these course content, shall we? What we got here? How to learn data structures and algorithms, right? Course introduction, code workspace tour. Hey programmer, max value is prime. Wow, those are so easy. Oh my gosh. Let's see. And like, so like whenever you go to an interview, apparently what you have to do is describe your solutions, right? You have to describe in big O notation how efficient your solutions are, right? So like if you like iterate over a set of data like 3 times when you could have iterated over it once and used like a hash table or something like that, then like, that's a better solution, right? It's a better solution if it takes less time because like say you were working at like big tech or some shit, and you gotta do a lot of stuff on a lot of data and you gotta iterate through a whole bunch of shiz, you know then if you have to iterate over like insanely large data sets over 3 times, like I don't know, we're talking like the millions of data points, that's gonna take a long ass time. It's gonna take a long time, you know. And there's ways to like solving complex problems and shit, like that, you know. So, but yeah, yeah, yeah. Anyhow, let's see. We're gonna go ahead and go through this introduction. It's gonna be like 2 minutes, I guess. We'll see what Alvin Zablan, educator, software engineer, ex Google. Oh my god, he's from ex Google. Probably he makes more money. Yeah, just saying that you worked at Google is like, or you even got past Google. Is like an accolade, but it doesn't really mean much anything anymore because there's so many fucking engineers now. But yeah, there we go. But it does help. It doesn't hurt to be an ex Google engineer slash tech lead slash millionaire. It does make people think you're more credible for sure. All right, what are you gonna load? Are you gonna load, buddy? Are you gonna load? Are you gonna load? Are you gonna load? But yeah, I don't know. I've been kind of in the creative slump lately, and I've been like, hanging around like Sponta a lot, and I feel, yeah, I still feel tired. Like I didn't feel re-energized. I felt like I just spent more time hanging out with like streamer friends and making new friends and like, oh my gosh. And they're like, "Are you gonna stream your side of this?" Blah 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 blah. I'm like, "No, I'm on break technically. Fuck you. I don't want to collab anymore. I'm all collabed out, man. Like, fuck, you know." And I'm gonna have to explain this to like Enderstein tomorrow. But I can't explain it to him because of my Discord is fucking locked. So yeah, thanks Discord. So I can't do that. So I'm just gonna have to like, I don't know, tell him no, I guess, on Wednesday and just like, I don't know, get back to programming, which sucks, but yeah. Oh well. And then I have to do like with the drama from people. I mean like other like I don't know, just like little in-group drama. It's like it's not really that bad to be honest, but it's like, oh fuck, it finally
Hey,
loaded.
programmers, and welcome to Structy.
Hey.
Structy is a course designed to teach you data structures and algorithms from the ground up, so you can stop the confusing lead code grind and start learning how to solve interview problems. I'm Alvin, and I'll be
Right.
your guide to data structure and algorithm interviews.
Okay.
The reason people find algorithm interview prep slow and frustrating is because they go about it in the completely wrong way.
Oh really?
They jump straight into leak code style problems without
Okay.
taking the time to learn the underlying concepts. They work
Right.
through lists of countless problems, but never develop real mastery for the data structures.
I'm
And as a
drink.
result of this, when they are confronted with a new problem, they struggle with it because they really only know how to solve problems that are identical to the ones they've seen before. And
Sure.
that's definitely not going to cut it on your software engineering interviews. They
Honestly true. Yeah. I don't know. It seems like, I mean, software like it's not enough to use like filter, map, or like reduce in your interviews now. Like if you're applying for a senior position, they fucking expect you to do like map, reduce and like filter and shit like that. You know, like they're expecting that. You know, honestly, if you can explain how map, filter, reduce on a very low level, then that's good. That's really good. Then that means you understand the technology, or at least you have some domain knowledge in JavaScript that maybe not a lot of people have, right? Like for example, filter's really fucking good, and like JavaScript sort is really good. It's based on quicksort. That's why I feel pretty confident whenever using JavaScript to use the sort algorithm for the most part, because it is based on quicksort, and it has its own little optimizations built into the language that are a lot better than that. But interviewers are stupid. People are stupid, and they want you to know way more than you'll ever need to know at your job. But because, maybe there's that one case because you have to go one abstraction level lower than what you're coding in to like squeeze out maybe a little bit of performance, which nowadays you can just say, hey, ChatGPT, I have this inefficient code. I want to rewrite this in Rust. Can we rewrite this portion in Rust? And then it'll just do it for you. It's like, what? Come on. Whatever.
Made the mistake of memorizing specific solutions instead of learning the generalizable patterns. If this sounds like you, then don't worry, you're in the right place.
Okay.
If you're going to pass your technical interviews, you're going to need to do more than just complete a list of problems.
Okay.
Instead, you'll need to develop your knowledge in a way where you can apply it to new problems when it matters most on a technical interview.
Yeah.
I know this because I'm an ex-Google software engineer, and I spent the better part of the last decade teaching thousands of software engineers how to ace their technical interviews and land their dream jobs.
Right.
In this course, we'll learn
No such thing, but okay.
data structures and algorithms in the right way. We'll start at the very basics, and over time, we'll increase the difficulty. You'll be able to practice a topic extensively before we introduce a new one. This is really key. There's going to be a strong sense of progression, and we'll increase the difficulty very slowly along the way.
Okay.
And I'll be with you every step of the way
What?
to explain each algorithm through our detailed code walkthroughs, as well as our easy to understand animations. I'm super excited to teach you all the tips and tricks you need to pass your algorithm interviews. So without further ado, let's jump right in.
Well, thank you. Let's go on to the next task, shall we? You know, I want to take a look. I'm kind of paranoid because I thought people would be like commenting. So like, you know, let me take a look. Let me see what's going on here. Hello, Gamer Cool. How you doing? How you doing? Great to see you. Great to see you, Gamer Cool. You know. Anyway, I guess I don't know why Botrix did. Oh, hello. Yeah. There you are. There you are. Wow. I was paranoid for a second. I guess Botrix is working. Sometimes it like intermittently goes out or something, but yeah. We're trying out the Structy thing, see if it actually helps with data structures and algorithms. Because like it's not enough to know how to make things anymore. You have to explain every fucking detail and say the O and N of every solution. So here we go. The things we do to get programming jobs.
Hey programmers, I'm Alvin, the creator of Structy.
Okay.
What I want to do in this video is give you a rundown on what you can expect on the Structy platform. Consider this the course introduction.
Okay.
And I really want you to use this product as a course and not just a platform for drilling random endless problems.
Okay.
So of course my goal for you is to be able to solve all of these really interesting data structure and algorithm problems, but I want to do that using a sense of progression. So let's go over how you can get the most out of this course. To me, progression is all about how we scale difficulty over time. And this is where a lot of students kind of go wrong in how they learn any topic, but in particular, data structures and algorithms. So let's say I made a little graph out of these. Unfortunately, for most students, they experience data structures and algorithms using a learning curve that looks something like this. And naturally, this difficulty curve is not ideal. It's going to lead to a lot of frustration, and it's really going to slow down the learning process.
Okay.
And to make matters worse, students often work through problems and topics in an order that is not logical. In other words, if you imagine that each bar here is a problem, they might explore problems in a fashion that looks something like this, where each letter corresponds to a unique topic.
Oh, yeah.
A disconnected topic order like this is really going to slow down progress, lead to a lot of frustration, and really feel unnatural for students.
It kind of does,
so on Structy, I've designed the order of the problems to really form a curve that looks something like this.
Oh, really?
And of course, we'll be exploring all of our concepts in a logical ordering. And so what does that mean for you? Well, you're going to start at a relatively easy level of difficulty, and we're going to ramp up over time. And over time, I'm also going to incorporate different topics. And whenever I introduce a new topic, I'm going to be sure to give you tons of practice on that same topic before switching topics. Okay. And as we get into the later stages of the course, I'm going to force you to recall really old topics. That way, you've mastered everything by the end of the course. And overall, you'll feel a lot natural progression in this design, and it's going to be a lot more fun to actually go through these different problems.
Okay.
All right, so I'm a fan of doing things step by step, so I'm going to give you some hard and fast rules you can use to get...
He's a procedural programmer, step by step. He's definitely writing those procedures. Yeah.
...the most out of this course. That is, what's our recipe to success here? Well, number one, you want to do these problems in order. And that even holds true if you're working through the free problems on Structy. I've organized things in a way where you'll be able to cover all of your core topics in a logical progression. So let's say you opened up a new problem. It goes without saying, the next thing you should do is just read the prompt. So read the narrative around the prompt and make sure you look at all of the different test cases.
Okay.
In addition to the text prompt, you're going to have two types of video assets available to you for every single problem. The first type of video we're going to call the approach video. In the approach video, what I'll do
All right. So this guy named VSCR on IRC like recommended this to me. You know, um, I don't know. I feel like this is insulting my intelligence a little bit, but I'm gonna give it a chance. It's kind of like, yeah. But I'm gonna keep going. I'm gonna give it a chance.
Is be exploring the concept at a high level. In other words, we're going to go over some pseudocode and give you all of the ideas you need to formulate the correct code.
All right.
In the approach videos, we're going to formulate and consider different strategies, and then we'll make an informed decision upon which strategy we'll use using some big O analysis. In addition to the approach videos, you're going to have access to walkthrough videos.
Okay.
And those walkthrough videos are actually going to be a recorded session of me solving the problem in some code. Okay. So that way you'll see all of the nitty-gritty implementation details. All right, so with these two types of video assets in hand, how should you use them? Well, my recommendation is after you read the prompt, if you have no idea what to do, that is if you're lost, then you should watch the approach video first, right? Okay. The approach video will give you that high-level background you need to attack that problem. And don't be too hard on yourself if you need to watch the approach video. Again, as we progress through the material in the course, I'm going to give you different topics, and so sometimes if a topic is brand new for us, you must be watching the approach video.
Okay.
Right? And don't worry, if you have to watch the approach video, I won't be spoiling too much of the fun. I try to keep things high level, that way you can flex your brain inside of the code walkthrough.
All right.
So after you watch the approach video, then you should try to write the code, and you'll know you solved the problem using our test cases. If you get stuck writing the code and don't know exactly what to do, then you can watch the code walkthrough. We'll I'll guide you step by step on how you can implement.
You see, the thing is, I can come up with a solution that works most times, but it's like I can come up with a solution and it takes me a while, but I can come up with a solution, right? But it's not efficient, or it's not the best, or for a certain use case, or I can't explain. Even if I do come up with the best solution, I can't explain why it's the best solution for that particular use case, right? So if something's memory heavy, I'm like, well, yes, this solution requires more memory because it's a trade-off, right? That was something I learned from doing neat codes, and just kind of doing it offhand and whatnot. It was something that was the thing I learned from doing neat code and watching the other guy explain it was that there are trade-offs in software, right? So you can write something that's very processor heavy but low memory footprint, or you can do hashing with hash tables, have something that's a higher memory footprint but has more and more efficient on the processing side of things, So yeah, that was one thing I kind of learned from doing neat code. But yeah,
the solution in the language of your choice.
Wow.
All right, so that's my main recipe to success. I'm going to add one more thing here. What I want you to do is also redo a problem until you don't need to use the approach and walkthrough video anymore.
Okay.
Number 6 here is really all about being self-sufficient. It's really okay if you have to use the approach and walkthrough videos, but you should keep redoing the problem until you don't need to, right? You want to be self-sufficient. To me, that's how you gain confidence with this material. Like I said in the intro, I designed the problem sequence to get harder over time. So if you can't solve the current problem that well, you should probably not move on, right? It's all about having mastery of our current problem before moving on to the next one.
Okay. Code Workspace tour. We're gonna get a tour of the workspace. How nice. What's next, buddy?
Hey programmers, Alvin here. Before I send you off on your programming journey through Structy, what I wanted to do is give you a quick little tour of the code workspace that you're going to be using throughout the course. So first things first, you're going to be noticing that for most problems, you're going to have 3 windows. The first window, you're going to have your problem that you need to solve, as well as some given test cases. And in that same window, you're going to have access to 2 different video types. You're going to have an approach video, which is going to be like a conceptual kind of drawing, walking through the thought process behind a solution to the given problem, as well as a code walkthrough, right? Which would actually be a video of me talking through my thought process as I come up with the literal code that we need to actually execute to solve the problem. In the final tab, you're also going to be given just the static code solution, right?
Wait a
second. Going to be
given
just the static code solution. A video of me talking through my thought process as I come up with the literal code that we need to actually execute to solve the problem.
Okay.
In the final tab, you're also going to be given just the static code solution, right? Which is going to give you the straightforward answer. One thing to note is for the walkthrough videos, by switching the language of choice in the top left, not only are you going to switch the programming environment, but you're also going to switch the content of the video walkthrough, right? So dependent on whether you're using JavaScript, Python, C++, or Java, if you select your language of choice, you will have the corresponding video walkthrough. So that's good to know.
I should
On the
probably do
right-hand side, you're going
Python,
to have
but
a pretty classic text editor. The
like I'm not super familiar with Python, but I could probably do it in Python. It would just take me longer. Well, thank you for following Super Sushi TTV. I really appreciate that. Wow. Why science? Well, because computer science. Wow, you're back now. Yeah, I am back. I am back. I am back now. Thank you for the follow, though. I really appreciate that. The thumbnail. You love the thumbnail. I know, right? I am back. Yeah. It's pretty cool. We're just, I thought I'd do something a little bit different. This is something I've wanted to do for quite some time. Yeah. Also, this is just sushi, sushi sniper, not sniper sushi, like sniper sushi TTV, just sushi. Okay, sniper sushi TTV. Okay, sushi. I'll call you sushi if you want me to call you sushi. Very well, very well. Hold on, let me just get this. Let me see if I can actually like resize this window. It's really difficult to resize windows with a tiling window manager. Sniper is the first name, sushi is middle, TTV is the last name. So are you one of those people that prefer being called by your middle name? Is that a I get that. I totally get that. Both of my siblings are the same way. They're like, they hate their yeah. Yeah, yeah. Yeah, yeah. All right, let's see what else we got here. Mm.
top right of that, you're going to have some options that you can mess around with. You can do things like
Ooh.
change your key bindings, use light mode or dark mode, as well as
Base.
mess with your font. You'll
Okay.
also have the ability to actually reset the code, right? So let's say you wrote some code here and you want it to reset to the original kind of default code. You
Cool.
can just reset it using this button.
Nice.
Useful. Awesome. You're also going to notice that for your actual execution of the code, you do have a terminal that's going to display any
What?
output. So for example, you're actually going to solve this Hey Programmer task.
I have my Twitch set to follower only? Ah, that's weird. Do I really? I did not know that. Hold on, let me check something. Let me check something. I did not know that. Let me just give me a second here. As peculiar. I guess we could open it like this. Oh, that's gonna be funky. Hmm. Yeah, is it really set to follower only? What the fuck? I didn't know it was set to that. I know it's set to that for like Kick, but not Twitch, honestly. Let's see sudden stream. Let's see. Wow, yeah, I'm glad I didn't show that. That would have been pretty lol. If someone told me at like 40 followers, I'm at 73 now. Wait, what? No way. That's wild. Let's see, enable clips. Let's see. Missions, my teammates. I don't even know like how to like maybe it's like channel related or something. Yeah. Is it like I don't know how to set that up to be honest. Like give me a second. Um okay, yeah, there's my Discord, Twitter, GitHub. Let's see. Maybe it was yeah, maybe it was moderation or something. Let's see. Block hyperlinks, chat. All chatters must have a verified email. Oh, is that email verification or something? Is that it? Okay. Let's see, phone number verification is off. Set all Twitch minimum recommendation. Subscribers modify. See, let's see, age verification. Unban requests enabled. Stop banned users from viewing stream. Private, that doesn't work, but whatever. Followers only mode. 0 minutes. Moderator tools pin message. What are you talking about? Like, what are you talking about? Honestly, like literally, it's right there. What are you talking about? What are you talking about? Like, you talking about like having to verify your email or something? Is that it? Is that it? Is that what you're talking about? I am in Stream Manager. Okay, Stream Manager, fine. Right. Okay. All right. Now what? Now what? Now what? It's gonna be funny because it's gonna appear right below here and then it's gonna appear right up here. Hit the three buttons on the chat box on the right. Let's see. Users in chat. Right. Broadcaster. Users. Oh yeah, yep. Is it pop out, edit layout or something? I don't want to edit the layout. That sounds like a stupid idea. I don't think I want to do that. I think that's a terrible idea. I think that's a terrible idea. Oh my God. This is way too much customization that I'm used to. The fuck? Like holy crap, holy. See here. No way. Just go to no way. Just go to the normal stream. LOL. Why do I listen to chat's advice for anything? Wow. Collaboration panel removed. Yeah, fuck collabs. Why would I ever do that? Well, I guess I won't see your thing ever again until I fix it. Um, okay. Yeah. And hit the settings button next to the bottom left. Yeah, yeah, that's where I was. That's where I was. That's where I was. The fuck? Oh my god. All right, all right, all right, all right. But yeah, like what are you talking about? No. Okay. You want me to hit the settings. Here's the settings, right? Chat bottom left. Go to stream like you're a viewer. Okay. Okay, I'll take it. So it's not stream manager, right? It's not here, like I'm a viewer, right? And then hit the settings button on the bottom left. Not there, like I'm a viewer. Okay. So I'm gonna go to my own stream. All right. Back to Twitch. Okay. All right, I'm back on Twitch, right? I'm gonna go search myself, maybe. See, Mayleyan01 or something like that. Yeah, I'm live, right? Two viewers. Comfy Chaotic Sus. Yeah, yeah. Yeah, that's me. That's me, all right. Yeah, yeah. Oh, yeah, now that's me, all right. Now I have to listen to myself. Yay! Okay, cool. I'm gonna pause that for a second. So you're telling me the button next to chat, that one, this literally is just to report my stream. There's no, what are you talking about? No, it's not there. It's not like, like I could delete your message. Are you trolling my, I know you, if I think you're trolling me. Are you trolling me? You Forgar? Wow. Ah. Anyway, I'm pretty sure it's fine. Lol. I got trolled. I got trolled so hard. Anyway, let's see. But you're saying it's follower only? Like, I don't think it shouldn't be follower only. Like, it shouldn't be like that, honestly. That's crazy. Like, how is it like follower only? Because like, I swear to God, it's not follower only. It's like, because like if we go to settings right here, like channel, like stream, it's like it should be like open. Like the only thing, like did it ask you to like have your, like how does that even work? Like why? That's so weird. Um yeah, I'm not sure what's going on there. Because like here's subscriber only. Oh, that's only subscribers only. Okay. Let viewers upload clips to their socials. Feature this clip setting. Moderators. Okay. Followers only is off, right? um any followers 10 minutes, like literally it's just off, like that should not be a thing. Okay, followers only, maybe it's this one. Disconnect protection, that's for clips. Okay, VOD settings, stream feed preferences, copyrighted audio warnings, low latency, disconnects protection. Followers only, permissions, raid, deny all raids. Okay, maybe it's not it. Let's try channel. Schedule featured content. Let's try. What do we got here? Link title. I might have to fix this later. I'm gonna have to fix this later. I don't have time for this, but thank you for that. I will definitely take a look at this in the future. We should probably continue this. Hello, Sans Sock. How you doing? I don't think I've seen you around here before, but you seem like one of the Undertale people that are coming around. I don't. I'm not gonna do Undertale for a bit. I'm gonna switch over to like programming and Night in the Woods and games that I actually want to play. I might revisit Undertale at some point though. So don't get too angry, please. I'll revisit it at some point. I promise. I just have to I have to learn things, and it's time to learn. It's one of those days. Here we go.
Task, and the very next task But I'll just put like a fake answer here. Let's say I'm going to return potato, which is obviously
Okay.
the wrong answer. If I hit test, it's going to execute my code. I'm going to see the output for the corresponding test cases in the terminal.
Nice.
Do note that the test cases that run in the terminal are exactly the test cases that you can see displayed in the prompt window over here. Now, as you work through the problems in the course, you can feel free to customize your layout, right? So you can drag these windows, resize them, and even use some of our different default layouts.
Well,
so make it home for yourself.
Okay, whatever.
All right, programmers, what I want you to do is hop into the very next task. You're actually going to work through your first problem. I'll see you there.
Oh, yeah, nice. Yeah, I might revisit that at some point, you know. I don't know if I will, but yeah, it's kind of like a one and done game. I want to go back and play, I want to play the genocide route on Undertale if I can. I think that would be a lot of fun. I really want to crush Sans. I want to crush his spirits in every possible way that I can with maximum determination. That comes later. All right, next task. We've got our introduction done. All right, hey, programmer. What do we got here? Welcome to Structy. Okay. Watch the approach video to a tab of this window to get started. Write a function greet that takes in a string argument S and returns the key hey S. No tricks here. Run the test to check your work and greet Alvin. Okay. So module exports S. So S is going to be okay, but what even is S? I guess I'll just return S. Return S. Okay. Or I could just return a string hey S. Let's see if that's what they wanted. Mm-hmm. How about okay, let's run that test. Let's see. Wait, what? I have to sign in? What? Okay. What? I thought. Okay, apparently I have to sign in. Give me 1 second. I'm gonna have to sign in on this shiz. Woo. Yeah. Here we go. Boop. I don't want to dox myself. That'd be bad. Okay. Okay. Hit that test. I'm gonna sign in with my Gargle account. You over there, Ashwan. Hopefully it doesn't like dox me immediately. I hate it when like you sign in at Google and it's like, oh, okay, there we go. There we go. It's fine. It's fine. Let's see. Let me check my profile just in case. Just in case. Okay, we're good. We're good. Excellent, excellent, excellent. All right, well, there we go. Let's get that back up, shall we? Alrighty, alrighty. Here's what we're looking at here. I'm gonna go ahead and move this. See if I can squish this down a little bit. I'll make this a little bit bigger, right? All right, and I'm gonna move myself. I think I'll move myself over here. Let's see, where should I move myself? Where should I move myself? Yeah, I could probably move myself over here. Yeah, I'm gonna probably cover one of the test cases, but yeah, here we go. All right. So basically, I'm gonna try to return S, see how that works. Unless I'm supposed to actually use that argument, but like I don't know. We'll see. Okay, let's see. 0 test pass. Okay, I'll just return S then, or something like that. We'll try to return S, maybe. Let's see. Or maybe it's like, hey, hello, Verkvon. How you doing? How you doing? Welcome, welcome. We're doing a little bit of, we're trying out the Structy course to see if it'll actually help me like learn algorithms and stuff. It was recommended to me by this guy named VSCR on IRC. So yeah, maybe instead we just return S and see what happens. Or God forbid, maybe it's actually maybe we'll just have to do something like this and then I mean, this is god awful, but you know, whatever. No? No? Okay. Wait. Warning, no output. What do you mean no output? What do you mean no output detected? What are you talking about? Test it, bitch. Oh wow, it actually works. Wow, so easy. Oh my gosh. I don't know what happened there, but okay. Easy enough. Max value. What do we got here? Okay, write a function max value, which takes an array of numbers as an argument The function should return the largest number in the array. Solve this without using any built-in array methods. Okay, no built-in array methods. Got it. Okay, cool. So, what's up? Well, hello, Tinsley Parks. How you doing? Welcome, welcome. ¿Cómo estás? Or should I say it? Feliz jueves. What do you mean, Verkvon? What do you mean, damn bro? What are you talking about? What are you talking about? Yeah, I've been programming for a while. This is more like a learning how algorithms things. So yeah, this is like recommended to me by like another programmer who he worked at Nike. So I never got to work at Nike. I worked at a whole bunch of random like startups from like fucking a job site that I will not mention. I'm a little tired, but I'm feeling better. You know, I have some water right here. Hold on. Feeling chill. Here in a like I don't know an hour, I'm probably gonna go outside and go shoot some deer. But yeah, to make my daddy proud. If I can't like like get a tech job, I can at least like kill a deer, and that will make him proud for some reason. But all right. So max value, right? Easiest way to do this: sort it, pick the first one. But you know, we have to do this without using array methods, and we have to do that without using sort. So that's gonna be interesting. Yeah, yeah. We could like brute force it maybe, and we could say we could take a stock. We could just what we could do. Oh, here's a good idea. What we could do is we could go through and check to see if we have the current largest one yet, and if it's not the largest, then update the number. So right. So let's say we have something called largest number, right? Right. If we have the largest number, right, is update that number, right? Pretty easy. So we only iterate through length as in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, but we want the 0, 1, because that's more relevant to our situation, I think. -1, right? And then we'll say I plus plus, right? Classic for loop. I don't think we're gonna need the classic for loop, but it's more efficient anyway, so whatever. So let me just boop, and boop, and boop, and that should fix things a little bit. All right. Alrighty, so we want to skip 1, I think. Largest, if largest. Actually, no. What we say is. Excuse me. Excuse me. Let me spit out my gum. God damn. Wow. You did it. Fuck yeah, Braz. Oh my god. I did it. What do you mean I did it? What do you mean? I don't know what you're talking about. Haven't solved it yet. Okay, I'm good. I'm good. I'm good. All right. Here we go. So we say if what is it? Let's see. Max if the largest is less than what? I right? Then largest equals I, right? Or we want to say num's I, right? We want to say num's I because that's the iterator. That was close. That could have been hilariously bad. Oh my god. So we'll say num's I, right? Yeah, if that, then largest equals num's I. Else, continue. Because we can totally do that in loops, which is amazing. Actually, I'll go ahead and just, I'm not going to do the fancy notation, because maybe this code editor doesn't understand, so we'll just use the regular notation, even though it's a little less terse, but like I should be able to do this. Okay. And just to check, we're going to console.log largest, and eventually we're going to have to return this from the function. So let's see how we did. let's do a test. Okay. Of course, 0 of them passed. I totally expect that. Okay, what do we have here? Let's see, for let I equals 0, blah, 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 blah. Syntax error, unexpected token. Okay, cool, whatever. Get rid of that. Okay, test it again. What do we have here? Okay, expect 10, actual undefined. I console.log and I got 10. Very nice. Awesome. So I'll just return the largest after this. So that should just work. So then we just return the largest, and there you go. So yeah, and that should just take O of n time because we're just updating one integer, which is great. So yeah, very easy. Hello, Jack. Welcome, welcome, welcome. Welcome to the stream. We're trying out some Structy problems at the moment, and I'm just kind of going through my process. And had this guy on IRC say, "Hey, this is a lot better than neat code. I'm using this to learn and how to do this on my algorithms because I don't really understand neat code." And I'm just like, I kind of understand how you feel too, because you really have to do some research on your tools and like, I don't know, there are ways to like solve things in JavaScript that are really troll answers, like I think on NeetCode, they asked me to do a encode and decode thing. It was an encode and decode problem. I could actually probably find that for you. Like, give me a second. Let's see here. Oh, yeah, here it is. Here it is. Yeah. Like, this is my neat code, right? This is my neat code, right? Like, yo, Jack, you'd like to jack off? Oh, I bet. Yeah, Jack over here, he's totally jacking on in there. He's saying, no, go away. Kind of reminds me of this. What was it? Oh my god. I love primitive technology, by the way. No, shut up. Shut up. I don't want that. Bender jacking on.
Hey, Bendy, why don't we ditch these organ sacks and hit the real party?
Right.
Count me in.
Hell yeah.
I'll drink till I reboot. Hey, what kind of party?
Oh my god. Basically, Jack. But yeah, welcome to the stream. Welcome. All right. Let me just let's get back to it. Yeah. I get a little distracted sometimes. Normally that would be good for other streams, but not this one. All right, let's run it. See, running script. What did I do wrong? What did I do wrong? Okay. No output detected? What do you mean no output detected? What are you talking about? That's the way, brah. Return largest. But I am returning the largest. What the fuck? What the fuck? Okay. Execute test cases. Okay. Expect 40.3. Actual 40. Wait, what? The largest is less than nums.I, but like, okay, what? Is it like how is 40 not less than nums.I, right? So like we have 10, right? So if we have 10, if the largest is less than 10, then we go. Otherwise we continue, right? Maybe we don't need to have this condition here. Maybe that's unnecessary. Let's try that again. Okay, what? What am I missing? The fuck? Okay, so test 1 fails. Actual is 40? Why does it stop at 40? The fuck? But 40 is less than, right? 40 is less than 40.3, right? Like, I'm not crazy, right? Like, hold on, hold on. Hold on. Okay. Okay. Let lol equal 40. Okay. Okay. Let's say lol is less than 40.3. True, right? So that would evaluate to true. Then if that's the case, then why what? Like what the fuck? Like, this is what I want to know, man. Okay. Maybe my loop is constructed wrong. Maybe I didn't need to do, excuse me. Maybe that's the problem. Maybe that's the problem. Okay, let's try that again. Wow, really? Nice, fucking nice. All right, yeah, that was the problem, I guess. I guess it's been a long time since I used a for loop like that. I don't usually write for loops. I usually write like for of or for in loops. So yeah, easy peasy, a lemon squeezy. Let's see. Course contents. Let's see if you had an answer for this one. See, is prime. Find the largest value in an array. No built-in methods allowed. Okay. 15-minute estimate. Hey, that wasn't so bad, you know? Let's see. I guess we'll try is prime. Right? Hopefully that records it. Yeah. Maybe. Yeah. Is prime. All right, see what we got here. Write a function is prime. It takes a number as an argument. The function should return a Boolean indicating whether or not the given number is prime. Okay. A prime number is a number that is only divisible by two distinct numbers, 1 and itself. Okay. Divisible by two distinct numbers, 1 and itself. Okay. For example, 7 is a prime number because it's only divisible by 1 and 7. For example, 6 is not prime because it's divisible by 1, 2, 3, and 6. Okay. You can assume that the input number is a positive integer. Okay. So, fuck you, Vert. No, fuck you. Oh my gosh. No fighting. No fighting. Oh my god. Oh my god. Weirdos. I have weirdos in my chat. Of course, I am the cartoon fox doing code problems. So, yeah. Alrighty. Let's see here. So let's see. We don't have an is prime, so we actually have to like figure out how to do is prime. But like, there's got to be a way to do it that's like not insane, you know? Because like, what's gonna happen here is like, if we get the number 2 or like we get like 10,000, right? We're gonna have to go through all those numbers and see if they're divisible by each other. So like, surely there's a way to write is prime in a way that's not like insanely terrible, you know? Because like we could just like do that, right? We could just go through, iterate through every single number and whatnot. But like, I don't know. I feel like we should like yeah, I feel like there's something better here. I don't know how to approach this properly. So let's go ahead and watch the approach video, shall we? I'm the
Hey,
oh
programmers,
my
Alan
god.
here. Right now, let's go over the
Hello, Ultra Ulsalad. Welcome. I somehow just woke up and couldn't get back to sleep, so I guess I'm up for the day. Lol. Hope you don't suffer too hard, you know. Yeah, we're doing something that this guy recommended that I do to get back into like algorithms and like apply for jobs and shiz. So yeah, I'm doing like job prep shit. No, I live on a effing mountain. What the fuck? I mean, there's caves and mountains. I don't know. There's some really dangerous caves in the mountains sometimes too. I remember there's like sulfur caves in like Colorado, and you can like just like die in there because they're just full of sulfur dioxide. And you can just walk in and die. It's great. I love it.
approach we can use for this is prime problem.
Okay.
So in this problem, what we're going to do is take in a number. What we want to do is return a Boolean, right? Indicating whether or not the given number is a prime.
Okay.
So recall from math, a prime number is a number that's only divisible by 1 and itself.
Yeah.
So if my input is 7, I should return true, right? 7 is a prime number. And the reasoning is 7 is only divisible by 1 and 7. Let's take a look at another example. Let's say I gave you a number like 11. 11 is also a prime number, so you should return true, right? 11 is only divisible by 1.
I don't think going to caves is a good idea in general. Wait, I read that wrong. I don't think going into caves in general is a good idea, considering how easy it is for things to go wrong. Don't become a statistic. Oh man, I know, but I love going in caves. This is the thing. Oh man, I love going in caves is the problem. But you know, knowing what's dangerous about them is precisely the reason why. You know, like, and you should never go caving without like 3 other people. That's like main rule. Like 2 people is not enough. You gotta have 3, you know. So yeah.
1, and 11. Taking a look at the opposite case, let's say I gave you 8. Here you'll want to return false. 8 is not a prime number because it's divisible by more than just 1 and 8. Right? It's also divisible by 2 and 4.
Yeah.
And if I can find like any other numbers that divide into 8, then I know that it can't possibly be a prime.
Right.
All right, so let's come up with a strategy for this one. Let's go back to the scenario where our input is 7.
Right.
So we know according to the definition of a prime number, it needs to be only divisible by 1 and itself. So to check if a number is truly prime, then we can just, iterate and check any possible divisors or factors of 7.
That's a lot.
So if I want to check the possible factors of 7, what range will they be in? Well, they're really going to be from 2 up to but not including the 7.
Right.
So notice here, I'm not including 1 because, of course, 1 is a factor of 7.
Right.
And I also don't include 7 at the upper end because, of course, 7 is divisible by 7. So I want to really hit everything in between. So how will this algorithm run? Now that I know the range for the candidates that could potentially divide into 7, I just want to iterate through them.
Okay.
Right? So I'm going to start at the first number of 2 here. And I ask myself, is my input number of 7 divisible by 2? Since it's not, I should just proceed to the next number and check it. Right?
I feel like this is like high school math that I've basically done before, because like I've had to like calculate is prime before, like what I would do, like what I should have done. I feel like I feel like this is explaining to me a little too much. Like I would have, if I didn't have this, I would have just gone to the internet and be like, all right, is prime. How do I calculate prime numbers the most efficient way? Literally, that's what I would do.
So now I check is 7 divisible by 3.
You could even like ask ChatGPT, but I guess you're not allowed to do that somehow.
It's not. So I keep going.
Okay.
Is 7 divisible by 4?
No.
It's not. So I keep going. 7 divisible by 5. That's a no. Done iterating through any like possible factors of 7, and I found nothing that can divide into 7.
Okay.
So now I should return true, right? I wasn't able to find any other numbers that divide 7, so by definition, it must be a prime. Let's take a look at the opposite scenario. Let's say I gave you an input like 9. We know that when we scan for potential divisors of 9, I look at all numbers from 2 up to but not including 9. So that means 2 through 8. And I just iterate in order. So I start at the initial factor of 2 and I check. Is 9 divisible by 2? That's yes. Number should them. And when it comes to implementing this like divisibility pattern, it's actually really basic. We can just use modulo. I'll save that detail for the full code walkthrough. What do we know about the time?
Shit, he's right. So like if you use modulo, right, that's brilliant, because like you can just use modulo. That's right. Modulo always returns a remainder, right, whenever you divide something. So it will always return the remainder. And if the remainder is 0, then oh my gosh, that's like then it's divisible by itself. But if there's a remainder, then it's not divisible it's not nicely divisible, right? So yeah, let's just like literally that's all I need to hear was modulo, right? Okay. So let's just do like a quick search, shall we? Okay. Modulo prime number calc. Yeah. Yeah, so like if any number, we just run it through modulo, right? So like modulo is always going to return the remainder. So if it has a remainder, then that means it wasn't nicely divisible. But if the remainder is 0, right? Like, right? Can I get like actually let's just do this right now. Okay, let's just do this right now, right? I'm going, bitch. Surprise, bitch. Hey, KM. Hello. Welcome back. Good to see you again, KM. I know you're working on your VTuber, so I can't wait. Can't wait to see it when it's finished, Do you know what program you're using to make it? Are you going to use Inochi or Live 2D? Meow. Yeah. Oh, lol. And I'm leaving your ass. Oh, okay. I don't know who you leaving. Oh, I guess he's in reference to the Choppa. All right. Let's see here. So let's say A equals 9. And let's say, wait, you all get that? Oh, wow. Okay. Wait, are you looking at match? Nope, I'm out. Wait, match? What do you mean? What do you mean match? What are you talking about? What are you talking about, match? What? What do you mean? Wait, what are you talking about? What are you talking about? No, I'm doing math. I'm doing math. I'm not looking for a match. What? I'm doing math, okay? Okay, so A, and we do modulo. So let's say modulo, was it? Yeah, modulo operator. Oh, yeah. Lol, I get it. I get it. A modulo 1 is going to equal 0, right? So, because obviously 9 is divisible by 1. So, what if we did A modulo 9? Well, obviously it's divisible by 1. Now, if we did 5, well, remainder 4. Well, that sucks. That means, why are we looking at math? Because it's we're solving these programming challenges because my friend said on IRC's like, here, you should try this. This is really good for you at interviews, because if you go to a tech interview, right? So what happens is, yeah, you can use all the fancy programs. It doesn't matter exactly because this motherfucker is smart fuck. Okay, I guess. Because at interviews, it's not enough for you to know how to build things anymore. It's like at interviews, they want you to study. You have to study this at interviews, basically. They want you to know how to solve problems in a certain time space complexity, right? I'd rather not look like at math again. I know. Well, how do you think your VTuber works, right? It's a bunch of math. a lot of shaders is a bunch of math, and I don't understand all that math, to be honest. I don't even understand how to make shaders, but like, I do understand big O of N notation, right? Well, I have a vague understanding of it. I have a very layman's understanding. So basically what it is, what this is all about is crunching numbers in more efficient ways, to get speed out of your programs and not to write bad code, essentially. Because sometimes corporations are like, we have a million bajillion results, and this code is super duper slow. Can you make it fast? And you look at the code, right? And you see that the solution is iterating 3 times over the same fucking data in the most retarded way the most retarded way possible. And so they give you these problems so they can figure out if you know how to sort through lists of data, or large lists of data in the most efficient manners possible. This is like big tech shit, and then people are like doing this because they want you to be smart for some reason. And this is the test to test how smart you are. However, you will never use this in real programming. This is more like how to pass an interview kind of thing as a programmer. This is how you pass an interview as a programmer. You do stupid shit like this to impress stupid people at interviews. And then once you've convinced them that you're smart enough, you go work and then you don't do anything at all. And you can be the 0.01 engineer, right? That, AI is going to come and put you on a performance plan now. They come up with AIs now to like put you on performance plans if you're a low performing engineer, pretty much. Pretty much. It's fucking stupid, People are trying to use technology to, like especially AI technology, or especially where it doesn't need to be used, and it's just, yeah, I hate it. But, we have to deal with the world that we're in because the people that have the most money have, they that's just how they want things done. That's just how they want to do it. So, yeah. All right. That got me on a talking terrain. Damn. Okay. I know, right? All right. So I think let's just keep going. I'm gonna keep going.
Complexity of this one. Well, if we say that n is our input number, then right now we're really talking about an O of n runtime. We're just iterating through possible divisors of our input number n.
True.
And we said that the numbers that we need to iterate are really just range from 2 up to but not including n itself. So that's roughly O of n iterations.
Yeah.
The space complexity here is going to be constant O of 1 because we're just using a handful of variables and we're not using any scaling structures.
Yeah.
So what we just described is a very classic linear runtime algorithm to check whether or not a number is prime. If you're familiar with some math, you can actually cut down on this time complexity. In other words, you could do better than O of n in terms of your time.
Yeah.
And it requires a little bit of math understanding, but it's really easy to grasp once you visualize things.
Math is
So
amazing.
how do we actually cut down on the complexity here? Let's say
math makes you a better programmer. It does. It really does.
I gave you some larger number like 64.
Okay.
According to our previously described algorithm, what we would do here is iterate from numbers 2 up to 63, right? Those would be like the possible factors of 64.
Fucking lame.
However, what we could do is really just check up to the square root of n only. In other words,
Oh,
instead of going 2 to 63, I can just go from 2 to 8, because 8 is the square root of 64.
nice.
We'd be saving a lot of iterations,
Hell
right?
yeah.
If we only had to go up to the square root of n. You're probably wondering, like, why is that okay to do, right? How do we know that we won't be missing out on any possible factors if we just go up to the square root of n? So here's where we can visualize things. I'll try to keep this explanation visual. That way we can just use our intuition.
Another thing is, like, what if I have a number that isn't so nicely square rooted? I guess, you know, like what? Square root of n only. So like, check factors up to the square root of n only. Okay, but like, yeah, I guess, like that's kind of what I wonder. It's like how would you even implement that?
We won't have to write any formal math proof, right? So consider our input number of 64. Let's say we kind of drew out a number line. So
Okay.
on one end of the spectrum, I have the number 1, and on
Right.
the other end, I have our full number, 64.
Okay.
And what I can do is plot out all of the factors of 64 just up front. They would be all of these numbers, right? The factors of 64 are 1, 2, 4, 8, 16, 32, and of course 64 itself.
Mm-hmm.
And so on this number line, we'll come back to it. What we want to do is try to understand what our algorithm needs to do, right?
Okay.
It really has to find some number a that divides 64, right? If I was able to find some number a that divides 64, then that means that our number is not a prime, right? And if I was able to divide 64 by a, that would result in some number b.
Right.
And just doing some simple, algebra here, if I multiplied both sides by a, that would also give me the equation 64 equals a times b.
Okay.
What we'll notice here is when you have like a factor of a number, factors always come in pairs. So what does that mean logically? Let's say I just chose some factor on this number line. Let's say I chose the first one. So I'm going to say that right now a is 1. What we're entailing is that this current factor of a, which is the value of 1, should pair up with some other corresponding factor. And that would be the 64, right? That would be my b. In other words, 1 times 64 is 64. That makes sense. And what we're really saying here is every factor has a corresponding pair. So let's say I moved both of these pointers inward. Right now, a is 2 and b is 32. Logically, 2 times 32 is also 64.
Okay.
In a similar way, 4 times 16 is also 64.
Okay.
And 8 times 8 is 64. At
Okay.
this point, both of my factors a and b are pointing at the same number 8. Right? Because 8 is the square root of 64, what we're saying is 8 times 8 is 64. And this square root of 8 serves as like the middle inflection point for our factor pairs.
Okay.
In other words, if I kept moving my a to the right and my b to the left, they would just cross, and I'd be looking at some duplicate pairs, right? 4 times 16 is 64, 2 times 32 is 64, and like before, 1 times 64 is 64. So if I just stop once I hit the square root of 8, I would have considered really all possible pairs of factors.
Okay.
So that'll be good to go. That's actually really easy to implement. Typically, every programming language would afford you a way to, in constant time, calculate the square root of a number. We'll save that detail for, of course, our code walkthroughs. So what would be our new and improved complexity here? Well, like before, n is our input number. Now our time complexity would be O of the square root of n. And our space complexity is still constant time. So if you wanted to go the extra mile in an interview, you should implement this small optimization, and it really speeds up the code nicely.
Yeah, I don't know. What if we could do better though? What if we could do better? Let's see. What if we could do better? That's like let's see. Calculate prime number. Let's see. O of 1 time. Can we do better? Find prime. How to find prime number of O in 1 time. Hell yeah! Here we go. We're gonna do better. Let's see if we can do better and do this in well, the sun hasn't come up yet, so we're still okay. See, it is impossible unless you have stored all the prime numbers up to 10,000. Okay, now I'm not entirely sure that my answer is correct, but I tried to search for the answer on the internet, and the best that came up with was a runtime of O log n to the 6th. Okay. Okay, it is doable using sieve of Eratosthenes. It is an array of bools, usually encoded as a single bit, byte/word d word array for better density of storage. Okay. Also, usually only the odd numbers are stored as even, except 2 are not all primes, right? Okay. Usually true value means it is not prime. Okay, so a naive O of 1 C++ code for checking X would be like what? Okay. Let's see, X equals, if integer X equals any 27, X is whatever. Wow. If the SOE is encoded as an 8-byte array, you need to tweak the access a bit. Holy shit. Wow, you really have to bit fiddle with this one. Damn. Damn. Holy shit. Holy shit. Okay. Wow. Can be learned at brilliant.org. Wow. Wow. That is damn. Okay. I used to think brilliant.org was shit, but like wow. I never would have guessed. I never would have guessed. Public static Boolean array is prime. Okay. If modulo n modulo 2, n modulo 3, n modulo 5, n modulo 7. Return false. I mean, yeah, we could do that, but it's not going to work for numbers up to 10,000, right? You know, like we need it to work for numbers up to 10,000. So like that is, let's see, source of the concept can be learned at brilliant.org. Okay, let's go take a look. And right, okay. Maybe not. Okay, so it's called, what's it called? Sieve of Eratosthenes. Let's see. In mathematics, the sieve of Eratosthenes, I can't say that, is an ancient algorithm for finding all prime numbers up to any given limit. It does so by iteratively marking a composite not prime multiples of each prime, starting with the first prime number 2. The multiples of a given prime are generated as a sequence of numbers starting from that prime with a constant difference between them. That is equal to that prime. Holy shit, okay. This is the Sieves key distinction using trial division to sequentially test each candidate's number divisibility by each prime. Once all multiples of each discovered prime have been marked as composites, the remaining unmarked numbers are primes. Okay. I don't know about that. I don't know about that. Let's see. Algorithm steps for primes below 121, starting from the prime square. Okay. I mean, it's kind of similar to what we were doing earlier, wasn't it? Okay. I'm actually kind of tired. You know what? I'm just going to follow that guy's advice to not try to do any better than that. It's probably fine. Okay, it's probably going to be fine. Okay. So, what does he say? Square root the number, right? So we square root the number is prime, right? So we're going to say math dot, I think it's square root, right? I think it goes square root. So we'll say let num equal math dot square root, right? And let me see, let me check something here. Let's see. Is that MDN? Okay, yeah, here we go. MDN.com. One of the best websites for looking up JavaScript stuff. Okay, so we're gonna say math dot square root. Yep. Ooh, what do we have? So we have math dot square root 2. What's this? Ooh, what do we have here? Okay. Get root 2. It's a static data property represents the square root of 2, approximately 1.414. Okay, cool. I think we just need math dot square root. Okay, yeah. Calc hypotenuse, calc hypotenuse, which is just math square root. Wow, literally just implemented Pythagorean theorem right there. That's kind of cool. All right. And but I don't know, he did something weird with like the square root of a number. If we get a nice square root, then that means, let's see, if we do the square root of 2, right? If you could do the square root of 2, what if we just do the square root? and that would just fix everything. Let's see. Let's just go through all these cases, right? Is prime square root of 2 is not a nice number. So yeah, it's true. Square root of 3, it's not going to be a nice number. True. Square root of 4. Um, obviously, a nice number, it's 2, it's false. Square root of 5, not a nice number. It's definitely prime. Okay, can you take, what happens when you take the square root of a number? Let's see. If you can't take the square root of a number and you get a modulo, or like a bad number, then maybe is prime. I'm just gonna see if this works. If num, how do we check to see that it's a whole number? You know, like that's what I want to know. So like, let me just do a quick search. Check if whole, if int JavaScript. Yeah, if we just do it, if we just do check if it's an integer, you know. Let's see what we have here. Is nan parse int value, and value is not nan. Is integer method. Let's see. Number dot is integer. Okay. So like I guess we could say number dot is integer, and that would probably do it. Okay, cool. Let's see. I don't think this is actually gonna work, but I'm gonna be amazed if it actually works. All right. If number dot is hey what? Hey yo what? Hey yo what? You mean to tell me? You mean to tell me this existed the whole time? What? You're kidding. Number dot is prime. Is that is that a thing? Is prime? Okay, I guess not. I guess not. I don't know why the this would give us anything, but okay, whatever. Oh, I see. Because it's listed as a function. Okay, okay. So we want is integer. If is integer num, then return return true, right? Else return false. Okay. Let's see if that actually works. I highly doubt it's going to work, but yeah, that's kind of what I figured. Let's see. Wow, expect true. Actual is false. Okay. So 2 is not an integer. Oh, wait. Oh, wait. We have to... Okay. But yeah, if it's not an integer, then we have to return true. So yeah, let me just fix that conditional a little bit. If it's not an integer, then it's true. Okay. Else we return false. Okay, let's try that again. Yeah, that's kind of what I expected. Let's see here. Let's take a look at 6. 6 actually failed, right? So like the square root of 6, right? What is the square root of 6? You know, like I want to console.log that, like console.log. Let's see, map that square root. I'm gonna just num, right? And see what happens. Okay, 4. Let's see, test 4. Okay, and that came out to what? Wait, what? Why is that not an integer? 4 13 tests pass? I was like seriously. Give me a second. Let me try, let me see something. Let me see something here. Okay, math dot square root of 6. Yeah, that should not be. Yeah, that's not an integer, right? That's not an integer, right? So, yeah, that should be false. Like, how is that not working? I don't understand. I literally don't understand. And let's see. And if we did, let's say number dot is integer, right? False, right? There we go. It's false. So why? Yeah, it should be false. So that would make sense. But how is test 4 failing? That doesn't make sense to me. Like what? How is that failing? Expect false, actual true. Wait, what? Impossible. That's impossible. Do it again. Okay. Here we go. How about this? Return number dot is integer math dot square root and then n. Okay. Test. What the fuck? How is that failing? That like what? That would have been reported as true, right? Because like, wait, what? What? Okay. Okay. If two, right? What's the square root of two, right? Like oh yeah, it's 1.41, obviously. It's not going to be a okay. 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 If n equals 2, n equals 2, return true. All right. Actually, no. Wait a second. Boom. I don't need to do that. Boom. Okay. Do it again. Do it again. Why? Why? Why is that? Because, like, why is the actual true? Is it actually true? Is 6 actually, like, 6 is prime? It should be false. Like, 6 should not be prime, because, like, oh, I see. I see. So if it's not, then it's going to be true, right? If it's not an integer, then it's going to be true, right? But but 6 is divided by 2 and 6, right? Oh, okay, that's where I'm fucking up. That's where I'm fucking up. Okay, that's where I'm fucking up. I realize that now. I realize that now. That's where I fucked up. Okay. Okay, let's see. Let's go through his solution. I want to see his walkthrough. Because I don't have the time at the moment. So he's using
Hey,
modulo.
programmers, Alvin here. Right now, let's go over the JavaScript walkthrough for this is prime problem. So hopefully you watch the approach video first. I will implement a can only be divisible by 1 and its factors of a 1 less than n. And I'll increment I as we go.
Okay,
And paying attention to the bounds here, right? I'm beginning I equal to 2 because there's no point of
right.
starting at 1, right?
Okay,
If I
yeah.
started at 1, of course, 1 is going to divide into my n, right?
Mm-hmm.
In a similar way, I don't need to include n for this upper bound because, of course, n is divisible by n, right? So I'm avoiding those. And as I iterate through these different numbers, what I want to do is check if n is divisible by I, right? So if n mod I equals 0. This is a very classic pattern to check if
Okay.
n is divisible by I, right?
All
Because
right.
if I divide n by I, its remainder should be 0. Always
Right.
remembering that modulo gives you the remainder of that division.
Okay.
Nice. So if n is divisible by I, then I've just found a factor of n, right? I would be a factor of n. So what I should do
Right.
is return false, because a prime number should not have any factors. Nice.
Right.
And if I'm able to finish this entire for loop,
All right. If n is divisible by I, then well, that makes sense. That's yeah. If that's one way to do it. That's the way to do it. But we wanted to reach for the stars.
and I don't find anything that divides n,
Yeah.
then I can verify it as true. I can return true over here. The most common mistake I see students make for a problem like is prime is they're tempted to write like an else and then write like else return true here. That's
Oh,
not
yeah.
going to be any good. This code will return true way too early, right? We know that the
Okay.
for loop has the job of checking for possible factors. So only after you check every single factor and have found none,
Yeah, I'm not
you can
doing that.
return true. So I don't want to put this else statement.
Exactly, yeah.
So let's give this code a shot. We'll see how it does, and we want to make any changes to it. So we're failing the very last example. A keen observer might note, for the last example, we're actually given a number of 1.
Oh.
It's kind of a special case in our code. 1 is actually mathematically not considered a prime, so we'll need to return false. Right now, our code is going to return true. And why is that? Well, if n is coming in as the number 1, on the first iteration of this for loop, we'd be checking if 2 is less than 1.
Okay.
That's obviously false. So this for loop has 0 iterations, which is why we just default and return true over here.
Okay.
So to handle that case, you just want to guard with an if statement.
Right.
So we'll check
Easy
if
enough.
n is like less than 2. Then we know it can't possibly be a prime number because 2 is the smallest prime.
That makes
What we
sense.
do here is just return a false. Technically, the complete definition of a prime number is a number that only has 2 distinct factors, right?
Okay.
Technically, 1 only has 1 factor, so it's not good enough.
Easy enough.
Cool, and there's our final solution for is prime. We could optimize this code. Right now, it
Yeah.
has a linear runtime, right, from this for loop, just iterating from 2 up to n, so roughly O of n iterations.
Yeah.
Expressions like this modular are definitely freebies, right? So we don't add those to our complexity.
Right.
Like we said in the approach, you can actually cut down on the time complexity, although this is already pretty fast, right? Linear is something we usually prefer.
It's
When
okay.
you scan for any divisors of n, you actually only need to go up to the square root of n. So if you wanted to implement that in JavaScript,
Oh.
I'll just show you. What you can do is do math.square.
Lol. Literally, that's the answer. Okay. Very well. Okay. There we go. See, I'm actually dumb. I'm not smart. I'm actually dumb. So I told you I'm dumb. I told you I'm dumb. So yeah. Here we go. That makes sense. So let's do that. Let's go ahead and implement this again. And we're gonna say, all right. We'll just do a classic for let I is less than n, right? I is less than n, obviously. And then we're gonna say I plus plus. Wait, no, not I plus plus. We're gonna say let I equals 0. Wait, yeah, let I equals 0. I is less than n, obviously, Oh, wait. Okay. Yeah, let I equals 0, I is less than n, and we'll say I plus plus. Okay, cool. And for the sake of this, I'm going to do, what am I going to do here? What am I going to do here? I'm going to say that. Oh yeah, and then we're going to do math.square. That's square root. I is less than the square root of n, I plus plus. And then I'm just going to go ahead and constant.log square root of n. So we're saying math dot square root of n, just in case. And yeah, I plus plus, and this will work whether it's and this should just work, honestly. So as long as it's less, if it goes over, then we already won. So yeah. So we'll say if what's it? I, right? Modulo n. If n modulo I, right? If n modulo I equals 0, right? Then it's perfect. Then wait. Is it then we return true? No, we return false. That's right. And then return true if that runs perfectly and whatnot. So let's try that. Okay. It expected true, actual is false. Okay, cool. Let's see here. So, right. Let's see. I equal to. Oh, I see. I think he said it equal to n, didn't he? I is equal to n, right? Or was it equal to n? I forget. Did he set that equal to n? I forget.
And here you
Right, here we go. So he's like n is less than 2, return false. Okay. n okay, n is less than 2, let I equal 2, right? Okay, I equals 2. I see. I see now. We reduce that. I equals 2, right? So if n is less than 2, right? Then turn false. Okay. Square root of n, I plus plus. Okay. Yeah, I did that. N modulo I equals 0. I guess maybe triple equals or something. For very strict equals 0. But, like, that should just work, right? I don't know why he does plus equal 1, but whatever. Okay. This should just work. This should just work, honestly. Okay, it fails on 2, interestingly enough. Expected false, but we got true. Interesting. So that's an interesting setup. I don't know what happened there. I'm gonna go ahead and watch because I don't have enough time to like do this shit. So I guess we'll keep watching.
and here you'll want to be inclusive. Right?
Inclusive, huh?
So that looks good to go. So as a quick aside, maybe unfamiliar, so I'll try math dot square root. Let's go ahead and find a square root of 9. And what I'll do is I'll run this manually. So if I hit the run button down here, I'm not going to run the automatic test cases. I'll just
Whoa!
run my file as a script here. So there I see 3. Nice. And the reason I want to be inclusive here is imagine that I had
Yeah, why do you want to be
like 4 as
inclusive?
my input. I know the square root of 4 is 2, right? 2 is
Mm-hmm.
also a divisor of 4. And you'll only be able to find that divisor if you are inclusive with the square root. So that looks
Oh,
good to go.
okay.
Let's go ahead and test this new
That
code.
little
And
detail.
this should give us a better runtime. It should now have a square root of n runtime.
A square root of n runtime. So square root n. Okay.
Base
Well,
complexity of either rendition is definitely going to be constant.
constant. I mean, that's better. That's better. That could be like on great scales. That could be like amazing. So yeah. All right. I guess it's 7:30. We actually caught like right exactly where I wanted to see. Yep. Yep. That was this submissions. Okay. I'm gonna run it. Can I submit it? I don't know. I mean, I did submit this, right? Let's see. 12, 14. Did I do that? Did I do that? I don't know what that is. Okay, let me go to the problem. I did the problem, right? I ran it, you know. What else? Oh, we have a terminal. That's cool. I guess we'll go course contents, right? Right? I did that. Didn't I do that correctly? Like, do I get to move on to the next one? Do I like what do I do? What do I do? Okay. No output detected. Execute. Okay, I have to test it, right? I guess. Hell yeah. Then run it. But I did do it. Like, what the fuck? Warning, no output detected. The run command is for sandboxing and will execute the file as is without injecting any tests. Did you forget to call and print your function? Call and print function. Nan. Okay. Running script. Let's see. That's weird. Okay. I guess that works. I guess we did it. All right. I guess we'll go on to the next one, right? Did I do that one? How do I know I did that in this one? This is what I want to know. Like what? Did I do it right? Did I do it right? I guess so. You know. I guess we could go back and like take a look at the other courses and see how we did. Max value, you know. See if there's a solution here. Let's see. Oh wow, he wrote it a little bit more terse. Oh, this is interesting. If let maximum equal negative infinity. What the fuck? What the fuck? Time 0n. Length of the array. Space 0, 1. This is like wow, okay. For let num of nums. Okay. Okay. If num is greater than maximum, maximum equals num. No shit. Yep. Okay. Okay. That's interesting though. I wonder why he does that. Why does he do that? Like that's what I want to know. What the fuck up? Negative infinity? Like what?
Iterating through every single number. So that'll be good to go. I'll loop. So I'll set up that variable. What I want to do is track the current largest thing I've seen so far in my array. So I'll create this variable called maximum, and as a nice default value, it would be nice if I can have it default to an arbitrarily small number. So what I can do here is utilize negative infinity in JavaScript. So what's great about negative infinity is it's guaranteed to always be less than any other number. Now what I just want to do is iterate through every element.
I see. Okay, I get it. All right. I'm gonna go ahead and call it here. I think this was a great stream. I think this is a good short little stream, good short little tech stream, you know. I gotta go get dressed and go hunting, you know. I'm gonna go ahead and get a deer before those hunters wake up. Hopefully it isn't light outside, but yeah. Thank you all for stopping by. My name is Melee Man, and I will hopefully see you Thursday in the AM, of course. So yeah, I'm gonna say ja matane. See you then. Bye-bye. Good time is...
Why? Why is it so difficult? This is gonna be all right. While you're Frank and Casey and all the other guys that are reading or jumping in, you didn't like, do they? Or didn't they? If you like people screwing with you because of whatever fucking reason, right? But your husband can't get a little action during the house. You just sit here and they act like nothing. Yes, it does. It has everything to do with it. It has everything for you to sit here and practice. Look at me when I talk to you. It has everything for you to do. But you sitting there and tell me. It has everything for you to do and sit there and tell me I'm not good enough for you. But you can sit there